Well, are you ready? Get ready, because today we're going to do a deep dive into the electric universe theory. So we're talking about a universe, right, where electricity, not gravity, might be the main force shaping everything. And I mean everything from galaxies to stars to, well, you name it. Imagine a cosmic power grid, right? Crackling with energy and connecting everything in this dazzling display of electric currents. It's a pretty wild thought, isn't it? Now, to help us navigate through this, well, electrifying journey, we have our expert with us today. They're here to break down these really complex ideas into, well, bite-sized pieces that we can all understand. So together we're going to unpack this theory, explore its potential, and then really put it to the test. Are you ready to dive into a universe of plasma and electricity? I know I am. So what is the electric universe theory? From what I've been able to gather, it suggests that electromagnetism, the force that makes magnets stick and electricity flow, well, it might be the dominant force in the cosmos. And it's not just about small-scale stuff either.
This theory claims that these vast electric currents, and they call them Birkeland currents, flow through space. And they shape galaxies, they power stars, and they even influence planets and comets. It's like the universe is one giant interconnected electrical circuit, you know? And this idea, well, it's not exactly new. Scientists like Christian Birkeland and Hannah Self, and they were real pioneers, I think. They recognized the role of electricity in space, and their work really, it laid the groundwork for this theory.
Yeah, it's true. Those guys were way ahead of their time. And, it's important to understand that the electric universe theory, it's a pretty radical departure from the standard model of cosmology, the one that relies heavily on gravity as the dominant force. It challenges some pretty deeply ingrained ideas in astronomy and physics, including those concepts of dark matter and dark energy, which, they're used to explain certain gravitational observations that the standard model just, well, struggles with.
Okay, so we've got this alternative theory.
Right.
And it's proposing electricity as this driving force in the universe. But what are some of the cool things it could explain? I mean, what makes it so intriguing? For instance, the electric universe theory, it has a totally different take on what stars are and how they work. So instead of being giant nuclear fusion reactors, like what the standard model suggests, the electric universe proposes that stars are more like massive electrical discharge phenomena powered by those Birkeland currents we just talked about.
It's like, imagine this. Instead of a star being like a giant campfire, right, burning fuel internally, it's more like a giant light bulb lit up by an external electric current flowing through it. It's a pretty different way of looking at things, wouldn't you say?
That's a really cool analogy. Okay, but what about all those craters? The ones we see all over planets and moons. The electric universe theory has an explanation for those, too.
Yeah.
They're suggesting that they could be, well, electrical scars formed by powerful discharges rather than, say, impacts from asteroids or comets.
Yeah.
It kind of makes you look at those pockmarked surfaces in a whole new light, doesn't it?
It's like, think about the process of arc welding, right? Where an electric arc creates this intense heat and can leave behind these really distinctive marks on metal. And proponents of the electric universe theory, well, they suggest that something very similar could be happening on a cosmic scale, with electrical discharges leaving behind craters as evidence of their power.
That makes a lot of sense. It's like a giant cosmic version of arc welding. And comets. Don't even get me started on comets. We're always told they're like these dirty snowballs, right? Releasing gas and dust as they get closer to the sun. But the electric universe, well, that paints a different picture. They see comets as electrically charged objects, and their tails and jets are, well, they say they're shaped by interactions with the sun's electric and magnetic fields.
It's really interesting, actually. They argue that the behavior of comets, especially those dramatic tails that seem to disconnect and reform, can be better explained by electrical forces rather than just, the sublimation of ice. And it is a pretty compelling argument when you look at some of the images.
Okay, so we're seeing that the electric universe theory offers some alternative explanations for things we thought we understood. It's definitely thought-provoking. But like any good theory, it needs to be put to the test, right? So let's switch gears here for a second and take a look at the criticisms and flaws that have been, leveled against the electric universe theory. It's important to consider both sides of the point, don't you think? I've noticed that some scientists they're pretty dismissive of this theory. They're calling it pseudoscience and a YouTube hoax. I mean, those are some strong words. What are some of the main criticisms, would you say? What are the weak points that critics point to?
Well, one of the biggest criticisms, I think, is that there's just not enough, direct observational evidence for some of the theory's key claims. For example, we know that Birkeland currents exist, but only on a smaller scale, right? We haven't observed them on the massive galaxy-shaping scale that the electric universe theory really, really needs. And that's a pretty significant hurdle for them to overcome.
So it's like they're taking something that we know happens on a small scale and just kind of blowing it up to a cosmic scale,
Yeah.
but without enough evidence to back it up.
Exactly. It's a big leap of faith that a lot of scientists just, well, they're not willing to make. They argue that extraordinary claims require extraordinary evidence, and the electric universe theory just hasn't, provided that level of evidence yet.
That makes sense. It's like saying, well, because ants can carry things many times their weight, they must be able to carry cars too.
Yeah.
It just doesn't quite add up. Okay, but what about the neutrino problem? We touched on that a bit earlier. How does the electric universe theory explain all those neutrinos coming from the sun?
Right. Well, that's another major point of contention for sure. You see, the standard model of stellar evolution, which, describes stars as these giant nuclear fusion reactors, it perfectly predicts the neutrino flux that we observe from the sun. But the electric universe theory, well, with its electric star model, it really struggles to explain this observation.
So it's like another point for the standard model then. It's like it has a solid alibi while the electric universe theory is still trying to, get its story straight. What other criticisms have you come across in your research?
Well, another common one is that the electric universe theory relies a lot on kind of reinterpreting existing data, to fit its own narrative. Instead of making new, testable predictions, a strong scientific theory, you see, it should not only explain what we already know, but it should also make predictions about things we haven't even observed yet, predictions that we can actually test,
So instead of letting the evidence lead to the theory, they're kind of trying to make the evidence fit the theory. That seems a bit backwards, doesn't it?
A lot of scientists think so, yeah. They point out that the electric universe theory often takes observations that are, well, perfectly well explained by the standard model. And they offer these alternative interpretations that are, well, difficult, if not impossible, to actually test.
It's like saying, we see this pattern in the stars, and it could be because of gravity, B-U-T. It could also be because of, well, invisible space dragons. And then when you ask how to test for the space dragons, they say, well, we haven't figured that out yet.
Uh-huh. Yeah, that's actually a pretty good analogy.
You mentioned that the electric universe theory struggles to make testable predictions. Can you give us some examples of where it, well, falls short in that area?
Sure. One example is the theory's explanation for redshift. Redshift is that phenomenon where light from distant galaxies appears stretched. It shifts towards the red end of the spectrum. And the standard model, well, it interprets this as evidence that the universe is expanding, with galaxies moving away from each other.
Right. The farther away a galaxy is, the faster it seems to be moving away from us. And that makes the light from that galaxy appear redder.
Exactly. Now, the electric universe theory, it offers an alternative explanation. They suggest that redshift could be caused by something called tired light. It's this idea that, well, light loses energy as it travels these vast distances, causing it to redden. But the thing is, this tired light hypothesis, it's been thoroughly debunked by tons of observations and experiments.
So they're proposing an explanation that's, well, it's already been ruled out by other evidence. That doesn't sound very promising.
It's kind of a recurring theme with the theory, unfortunately. It often clashes with well-established scientific principles and observations.
Okay, so we've spent, well, quite a bit of time looking at the criticisms of the electric universe theory. But even though it has all these challenges, it still has people who believe in it, right? What arguments do they make in its favor? I mean, we know it offers these alternative explanations for stars and craters and comets, but are there any other strong points that its supporters really highlight?
Yeah, definitely. One of the things that proponents really like is that the theory tries to, unify the fundamental forces of the universe. The electric universe theory sees electromagnetism as this primary force, with gravity playing, kind of a secondary role. And this really appeals to the desire for a simpler, more elegant model of the universe, where a single force can explain, well, a wide range of phenomena.
So it's like they're saying, why have two forces when one will do?
Yeah.
It's like they're going for a more unified view of physics.
Exactly. They argue that the standard model, with its, separate forces and its need to, invoke things like dark matter and dark energy, is just too complex, too convoluted.
It's like they're looking for a more streamlined explanation. They wanted to simplify things and reduce the number of unknowns.
Precisely. And, this desire for simplicity and elegance, well, it's a really powerful motivator in science.
Yeah, I can see how that would be appealing, but does that simplicity, does it come at the cost of accuracy? Does the electric universe theory sacrifice, explanatory power for the sake of a more unified view?
That's the million-dollar question, isn't it? And it's one that scientists they're still grappling with.
Okay, so it's time for a thought experiment, I think. We're going to tally up the good and bad points of the electric universe theory and then see where we land. It's like a cosmic court case, and we're the jury, and we're weighing the evidence for and against. So on the good side, we have the theory's attempt to unify the forces of the universe and its alternative explanations for things like, stars and craters and comets. Let's give it a point for each of those. That's 3 points for the good side. Now, for the bad side, we have the lack of direct observational evidence for its key claims. We have the reliance on, reinterpreting existing data rather than making testable predictions, the failure to adequately explain things like the neutrino flux from the sun, and, the conflict with well-established scientific principles and observations. That's 4 points for the bad side. It seems like the bad side is pulling ahead.
Yeah, it does look that way. But remember, this is just a simplified tally based on our discussion here. It's not like a definitive scientific judgment or anything, but it does highlight the challenges that the electric universe theory faces in, gaining wider acceptance.
So it's like the electric universe theory is losing the case, but the jury's still out.
It's like we've gone down this rabbit hole, haven't we, into this world of electric stars and cosmic lightning bolts, and it's easy to get caught up in the excitement of it all, But I think it's important to step back for a minute and remember that there's a whole other side to this story. So after weighing all the arguments, all the evidence, where does that leave you? Are you totally captivated by this electric universe idea? If you are, that's fantastic. Keep exploring. Dig deeper into those pioneering works by Birkeland and Al Venn. Dive into those claims made by proponents like the Thunderbolts Project. Let that curiosity lead you on an amazing journey of discovery. But here's the thing, and this is super important. Don't stop there. Remember that stack of sources you brought to this deep dive. We haven't even touched on all the counter arguments and evidence from mainstream science yet. How do physicists and astronomers explain those same mind-boggling cosmic phenomena?
Those quasars and craters, those majestic galaxies swirling through space. How do they explain it? Healthy skepticism. That's your superpower. Don't just take any theory, whether it's the electric universe or something else at face value. Look at the evidence, weigh the arguments, and most importantly, draw your own conclusions. That's what it's all about.
Yeah, you got it. The beauty of exploring these alternative theories like the electric universe, it really lies in the questions they make us ask. They challenge us to re-examine what we think we know, to look at the universe with fresh eyes and consider new possibilities. Who knows? Maybe those challenges, maybe they hold the seeds of breakthroughs that we can't even imagine yet, just waiting for a curious mind like yours to unearth them.
I would have been on top of the charts, but it's politics. You do some gimmick shit and post, you get a lot of clicks. Drop some real shit and they probably won't acknowledge it.